Hello, my name is Marcin Kubacki, I'm Chief Software Architect, and today's OVP webinar is all about Ansible. We are going to cover basics of the Ansible itself. So this is what I thought recently, that we have already covered some additional enterprise-grade tools provided with the Ansible Red Hat ecosystem. But what I was actually missing was the part dedicated to basics of the Ansible itself. So we have released just the second part of our Ansible ebook. And this ebook covers basics of the Ansible. It's short, it's easy to read, and actually it gives you an easy start to the topic. So we really recommend you to download from the OVP website. And today's webinar actually is covering parts of this ebook as well. So we are going to focus on the Ansible conditionals, handlers, and loops. So let's start with the basic overview of these. So first of all, we are going to talk about the conditionals in the task statements. Remember that the Ansible playbooks, well, obviously playbooks, like the name actually speaks to itself, it's set of plays. So a set of tasks executed against set of the hosts in your inventory file. You can define the variables for, let's say, to the scope of a given play. And this is actually a good example. You have a var section in your play, and then you want to actually run specific tasks only when the condition is met. Notice that in the task section, I have one task with some name task based on my mood var example, with the debug debug module, which is going to print a simple message with variable being injected into this message. That these double brackets in here allow us to inject variables. Now in the when section, you would like to create a appropriate condition so that this task is only executed when it is needed. With the YAML files, when you have the Ansible playbooks, you don't write the playbooks like in the regular languages like the if statements, etc., etc. So it's not a script. It's more rather declarative approach in this case. So I have when statement, sometimes applied multiple times on different tasks, so that these paths may not be instantly visible whenever you look at the playbook. Or I have this when statement including additional plays from other external files. That's actually a preferable approach in many cases because it is more easy to read. So I have a simple example in here, but notice that here, whenever I have a sort of switch case example, I'll have two tasks, one after the other, with the different values of these my mood variable. So it is quite common to see some set of such tasks being included or not, one after the other, inside your play. Notice that I have double equal sign. It's using the Jinja language to specify the conditionals in this case. And in my case, it is just pure equality operator. Now, conditionals can also use facts. Okay, so variable, you can say that a fact is sort of a variable either defined by you, like with the set fact module, or these provided already by the Ansible engine when these facts are gathered during the execution. So fact gathering is a process that is executing usually as the first step before any other tasks are being executed. It can be optionally disabled. but it provides a wide range of different information about the host. In our case, we are using Ansible distribution to specify that install Apache task is going to be executed either when Ansible distribution is Debian or it's Ubuntu in this case. If we and we are using actually apt module. Notice that there is an apt module. It's dedicated for the package management on the Debian based distributions, and yum if we are using Red Hat based distributions. So I have two tasks, and switch case sort of approach allows me to differentiate that the same task is going to be executed in a different way for different distributions based on a variable. So when conditions can be quite sophisticated, they can you can put additional filters in the conditions. You will notice that later, and you can also have well, string comparison or number comparison, etc. Now, variables also allow you to can be sort of recorded during the execution process for the task, let's say. So you can register the output of the previous task, and based on the previous task, you may proceed or not proceed with the other alternative tasks or other tasks that in your play. In my case here, I have the yum. It has it registered the HTTP results, if it's present or not, and only we are restarting the HTTP server if the previous task has changed. So the module yum will report that the task has been changed if the package has been installed, or updated actually, because the state is latest as well. If not, so nothing has changed, there is no reason to restart HTTP server in this case. In shell script, you could typically write it in set of if conditions, like if it has been updated or if it has been installed, then execute restart. But in Ansible, you need to sort of make it happen in a declarative way. So the HTTP results is actually a more complex object where you can, with appropriate fields like the changed state, reported for the task that it has been registered for. So HTTP results variable is actually a sort of a structure, data structure, or on an object, you would say. Now you may wonder that, okay, but I may have multiple tasks that can result in the HTTP server being restarted, okay? And this actually brings me to the handlers. Handlers are more reactive components of the playbooks. Handlers are responsible to be executed as the reaction for the specific event. In my case, I will notify this handler. Notice that there is additional section here in my playbook. I have handlers and I have named handler. I can refer to it later in the other tasks, and the service needs to be restarted. Okay, and now whenever I will have a situation that the HTTP server has been updated or installed, it is going to be invoked. Okay. One very important thing is about the handlers is that if I have multiple tasks that notified the handler, like I have an update of the package and maybe configuration file has been changed, okay, so I don't have to restart it multiple times. In this case, notice that the first one is unchanged, the second task is changed, so handler runs once. Now if both has been changed, so I have the file that needed to be copied there, I have the package updated, I will have this handler executed again once, which is very cool. And notice that it is going to be executed at the end of the play in this case. I have also in here a situation where nothing has changed, so I will not have to create complex conditions in my playbook that I need to register the output of the first task, output of the second task, and only if one of them has been changed, then restart the server. Okay, so this would be unnecessary, and as you can see, Ansible provides you built-in tools to handle such situation. Now the handlers is one thing, but I believe that something what would be even more convenient and more often you would see that in the playbooks than handlers would be the loops. So when you start writing a playbook, a script, or whatever, then usually as a programming language, you will have a situation at some point where you would like to execute the task for some set of or list of the entities. And in my case here, I have tasks that I need to ensure that the first user is present, that the second user is present, and the third user is present. And modules, not all of them, well, most of them I would say, they provide basic functionality to act on a specific item, let's say on a specific entity, but one entity. And now the problem is that you would like sometimes to pass multiple properties, multiple attributes to be verified. And to achieve that, you can have a loop. Notice that instead of writing 3 different tasks, and it would be a nightmare if I have a list of the users read from some external source, I would like to have a loop that is run over specific set of the strings in this case, actually, right? So this is a very basic loop that that allows you to have the iteration of the specific task. And notice that whenever I execute the task, I need to refer to the value of this iterator, let's say, right? Like in a regular loop, you usually in a programming language, you have some kind of iterator. Then this iterator by default, it's called an item. So item in here is going to be passed as a variable to the username. And I will be able to actually run this task multiple times with this short notation. Now, before we actually proceed with the questions, because this was too fast, now we will have a live demo. So notice that a few words maybe about the setup that I have prepared for you today. On a daily basis, I use IntelliJ actually, so this is not that is obligatory to run playbooks. You can write it in basically everything what you would like to use. I use IntelliJ because it supports multiple language actually, and it's working fine with the YAML languages. Plugin for the YAML files are both supported for the Ansible playbooks like I have right now, but it can also be used for some templates like AWS templates, for instance, and it usually it works, sometimes not. Like for today's session, this IntelliJ plugin doesn't work as I would expect it, so the completion may not be always working in all cases. Nevertheless, I have, as you can see on the left, several playbooks for free to demonstrate few different examples how to use conditions, handlers, and loops in few contexts that I will demonstrate. Now I have a host file. It's actually an inventory that I have 2 hosts. One, it is going to be local host connection to my machine, so it is actually a Mac. And I have a remote machine. Well, this remote actually is sort of remote because it is a virtual machine running here with the CentOS stream installed. So this is the one that I'm going to execute against the playbook against. Now, with the controller of the Ansible, in this case, residing on the local host. So I'm going to execute this on my Mac machine, connect to the remote host over SSH, and execute some playbooks against this machine. First, the playbook is going to be executed against two machines. So notice that the first condition, 01 playbook, right, is going to be executed against all hosts. Ansible is also, when we talk about loops, it's worth to note that the idea of Ansible is to actually specify a group of hosts that you execute your playbook against. So you will see that each task is going to be executed one by one on multiple nodes, multiple hosts, in this case my local host and the other one, if the all variable is specified in here. Let's start maybe with the overview of this playbook. So I will execute it here so that we will have the output. Notice that I will use the Ansible playbook, and I need to pass the inventory file. I'm not using the global file that I have. I'm using the dedicated for this session, the playbook name, and I'll pass external variables. So we talked about the conditions, and in the book that I have mentioned to you, we actually describe multiple different ways to use the variables, and Ansible has tons of the places where you can put variables. One of them is actually a command line, like I'm using right now, but the other one actually is the playbook itself. So I have special task variable in here. I have host to check also in here, and I'm overriding this variable. So host to check is not defined in the playbook. So if I forget about it, the playbook execution will fail. Now, if the special task is here defined, I can actually put it to true. I will override the variable, and based on that, I can instruct my playbook so that it needs to include this special task. Notice that well, first it connects to the host and it gathers the facts. So the Ansible OS family, OS host name, like I have in here, this has been gathered in this initial step. Now, once I have this, I'm going to the next to the first task in this case, right? So before even very first task has been executed, I have this gathering facts task first to be executed. Now, notice that there is a when clause. It is a boolean, so I don't have to form any specific sophisticated condition, because it's a boolean that I just can give it by the name. So if when special task, then it is actually true behind the scenes, then this task is going to be executed. Now, we have the host info example in here, so I'm going to show these variables just to present the regular task that is executed against every single host. So there is no when condition in this case, so this is a regular task executed always. But if I have this when condition here being met, so my host to check, which was passed here as the local host, I will execute the uptime as well. So here we will get into the while there is a failure in this playbook, we will have to solve this particular issue. I have this variable defined. I'm able to control which parts of the playbooks are going to be executed. So for instance, I would like to check the local host in this case. The special task is going to be the default to false. Now I will have this okay, host to check, actually it needs to be an IP address, so we will have to use something meaningful. What is returned in there? Localhost is the wrong value, We can control that. Now we will paste the value. And notice that this additional info task has changed now, right? So the condition has been met, and I'm doing something what is not really a good example. I'm using a shell module, which is your last resort. You are supposed to use always the modules if they're available, and I'm registering the variable in here, so uptime result. Notice that the additional step is also going to be executed conditionally, so only if the IP address is exactly what I have passed, or because I can also build more complex example, some IP address that has been arbitrarily chosen in here. Now, another thing is what I recently found, which was not that obvious, is that at some point you would like to define defaults in your roles. Okay, we'll get into the roles in the future, but in the playbooks. Okay, so and if you define the value like in a numerical way, like 1, 2, 3, etc. So it is actually defined as a number, and later you will have a normal comparison between two integers. However, if you would like to define them as the value of the number expression, like the multiple of 1024, for instance, I would like to have as the requirement for whatever I have, like RAM, CPU, or whatever, then you cannot do that unless you put that in the brackets, and the this is going without this not brackets but quotes. Without these quotes is going to fail. However, if I put that in the brackets, this is going to work, and I will have required variable defined. Now, the problem with this approach is that it actually results in a string, and it, even if you pipe it here internally, it is this int also is not going to be interpreted after it is actually converted to string. So notice here that whenever I have another condition that required is bigger, higher, let's say bigger, the value of the required is higher than the available, then I have this condition failed. So I want to fail my playbook if it is not met. And notice that, well, 2048 is not higher than the 10,000, so something is wrong. And the problem is actually the string value. So to actually solve it, we will comment this step out, and you need to remember that these conditions are evaluated, and you can pass filters actually to these conditions as well. So I'm, in this case, converting both of these values. You need to convert both. And this is going actually to result in the correct interpretation. So in this case, the second condition is actually okay. So it doesn't report failure because now I'm comparing two integers. Now, my last step here is that you also are able to use these variables, conditions actually, to use form conditions inside your template files. Template file here that I have is a simple template file that is going to have its contents based on the values of what Ansible passes to the playbook. Notice that, well, first I have a comment using this Jinja2 syntax. Then I have inside the brackets and %, Ansible OS family, which is basically your gathered fact, right? You also can use your own variable set facts that has been defined in here as well. Now, if it's Debian, then it's okay. Then it's else if, elif, actually, it's Red Hat. Then it's else, I don't know what kind of OS it is. And I have actually two operating systems in here. So the last step, prepare file, has been executed on my remote OS, and now let's check the contents of the file. This is Red Hat, okay? And in my local host, I don't know what OS it is. The same step executed against two different machines, and it interprets values depending on it interprets your variables, and based on my conditions I have different contents of the same template. Now let's go to the handlers part. So with the handlers, I have a slightly more educational example than it was on the slide. So notice that I have the command that obviously is going to change. So the shell invokes the uptime, and let me execute it. It's gathering facts again. And notice that, well, this time I'm executing it only for the server. So server here, hosts, actually relates to the section of the servers basically that I have in my inventory. I have only one in this section, so this is executed only against the test.local. First task is executing shell command, and I know for sure that the uptime is going to report that something has changed always. Okay, and then I have a task which does completely nothing. Debug messages, debug module actually is a good example of a task that doesn't change at all. And then I have again the uptime, and all of three of them will notify some handlers. And notice that first one, restart service, actually should print restarting service, and this one is supposed to invoke restart service 2. So my restart service 2 is not being invoked at all. That's the first thing to notice, because obviously the task has not changed, so the expected behavior. Another thing to note is that even though I have restart service in here and task has been changed, it hasn't been invoked, so I don't see any restarting service at this point. These are going to be executed later after the play finishes. And finally, you have another notification to restart service. Again, if you have notified the handler, it only is going to be executed once. In this case, I have running handler at the end of my play, and it is going to restart, let's say, service 1. Well, in our case, it just prints the message. It doesn't have to restart anything at all, but just to prove the point. Remember that handlers are quite handy, and if you're using roles, there is a dedicated folder where you usually define all of the handlers. So if you have more complex role, it has its place, so it's easier later to track where the handlers are defined. In my case, it's a simple play that has handlers inside, so I don't have to create additional files to be included. Now, the loops. This is something what I really like about the Ansible. A loop for SSH, right? So this is what people say, but in this case we are actually going to focus on the loops that are dedicated for the tasks. So I have a task and I would like to run it multiple times. And for people who have been using Ansible a bit longer, the very first thing the clause that is used for loop in the past, it was with items, and this is deprecated at this point. However, it's worth to show it in here. So let me invoke the 03. It's been a bit longer loop, example. So let's start with the very first loop. So notice that my with items, it's a bit tricky. Actually, it has 3 items. One is 1, Second item is actually an array of two numbers. It's 2 and 3, and then I have 4. But whenever gets executed, actually with items flattens all of the lists. So you will notice that it is 1, 2, 3, 4. It has been executed 4 times instead of 3. It's very important. And now, at some point, let's say a few versions back, loop has been introduced as, let's say, now the official keyword for looping over some set of items. Again, I have the item as the variable, so nothing has changed at all. But notice the difference how it gets executed in here. In loop 2, I'll have these 2 and 3 being passed as the variable. So 2 and 3 will be an array that is passed as the item variable, and it gets printed in here. So I have the variable item, it has 2 and 3 instead of 2 separate invocations. Now, to make it work again, exactly like it was in the past, so it is a bit maybe rare to have such strange lists, but let's assume that you have some input which can actually provide you some input dynamically, and you may expect such behavior. How to actually solve this? So inside the loop clause, you actually can evaluate an expression. So notice that I have the same array which has item 1, an nested array inside is with 2 and 3 numbers, and 4 as the last item. I'm using flatten filter, and 1 is actually to make sure that only the first level is going to be flattened. So you can control this behavior through this variable as well. And notice that this time loop 3 looks exactly like it was in the past. So it is exactly the same behavior, and this is the way sometimes you may need to do. So you can manipulate the items, the list items on the fly using the filters. Now, loop has also loop control option, so it allows you to provide the number, let's say custom name for the variables. And notice that I have the loop var defined and set to number. So I'm going to use, instead of item, I'm going to refer to number in this case, and my number is 1, 2, 3, 4. It has been defined for this loop. Now another example of using the loop is, well, in this case it's line in the file. So we have a config file with multiple variables, some of them are defined, some of them not. Instead of using block in the file, you may just want to replace the values of individual lines, like I have actually in this example. So my test file is actually going to contain 2 lines with key value approach. So this is quite common in Linux world to have some properties file being defined. Now I'm using line in file module, which expects obviously the destination file. This is on the remote host. I would like to create it if it doesn't exist, and then I would like to find a key. So if it's property files, you have a key value pair, so you will have the com method or TCP port being searched starting from the beginning of the line, and then I have some set of spaces. So I don't have too much against the complete line. I will expect it to be just separated later by the tab key. So that's how I define, let's say, the key of the file that I expect to find using this regular expression. The actual line that I would like to make sure, I have specifically say make sure, because this module is going to be executed conditionally. So it's going to be executed only if the regular expression has been matched. Not matched. So if the line is not present in the file, if I don't have any variable that defines this value, not necessarily the one that I want. Okay, I can have the com method set to the UDP, for instance, for some reason, and this is just the checking the beginning of the file. Now I will put a line in the file with the key and the value. And notice here that it is a quite a bit more complex example of the loop, because now I'm passing with every iteration a structure, a data structure that is that allows me to an object, let's say, I would say even an object that has key and value defined. So in every loop entry in here in the brackets, I will have key as the definition of the property of this object, of the item object. This is going to be set to the com method, and value, this is going to be a value that I would like to inject. And this pair is going to, this object is going to be later referred to with the item dot. So the dot is the character that you would like to use inside the to refer to the specific properties, and then make sure that is present. So notice that in such way I will have executed this particular task only on the lines which are not present, but for all keys that I have in my list with corresponding values. So we can have not only pairs, you can have more complex objects defined as well in such way. And notice here that I have changed, I have this file being changed, and this one is going to be in the temp03. It has defined, but if I, let's say, delete one of the lines and re-execute this playbook, this time it is going to notice that only one line needed to be added here. So again, 03, the line has been added. So the obviously in such way the order of the lines is assumed that it doesn't matter, so it has been just added at the end of the file in this case. Now what I'm doing right now here is using register to register the output of this module. So every module has some kind of the output, and we really like to use that for the integrational purposes in the infrastructure related activities that we have, to call the APIs. And URI module actually works pretty fine. Does the great job to do that. So because you are able to easily invoke RESTful APIs, and you also are able to have a sort of ready JSON. You can traverse the values that have been reported by the JSON and query appropriate field if necessary as well. So the register in my case actually has a bit simpler values. It's a bit simpler case, and notice that it is not registered for one or last invocation of the task. It is actually invoked. It collects all of the results for all of the items that the loop has been invoked for. So notice that I have the changed true. Okay, you have changed. All items have completed, so you can have a ready message. But inside the results array, I have the results of individual invocations. I have 2 invocations. That's the end of the first one, and that's the second invocation. Notice that you are able to see the module arguments that has been passed. So in this case, that's the line, that's the regular expression. So notice that I have all of the values being reported in here. Now I have registered that, so I have shown you the values, but now once I have it, I'm able to loop over the results of the previous module. So imagine that you have the API call where you are able to list all of the values of all of the entities, I don't know, users in the system, for instance, right? And you would like to make sure that the users in the external system, all of them have been defined in the other system. So you will register the output of such call, and then you will be able to traverse it. In my case, actually, notice that I'm looping here over the results array. So this instantly has become an object, well, an array object that I can use and pass inside the loop variable. So I can loop over a collection in this case. And in my case, the item is quite complex because it is the all of, well, basically everything here. It's a single entity like this one. That's everything that is going to be passed, right? So this everything, all of the properties have been passed here. And notice that the message in my case is very simple. The variable. Now I'm traversing this object because item relates to this very complex object that I have. I have here. I would like to show what was the regular expression actually, right? And it has completed, or if it has completed or not. So I'm going to the details item dot invocation. It's here. Module args. It's here. And then regular expression. It's here. Was changed or not. So the item changed is going to be this flag in my case. And I see it was true or it was false, depending on what was the status. So I'm able to loop over the results of the other modules as well. Similarly, like I can have the conditions based on the results of the other modules as well. Another example is that in some cases, when you are, a good example is actually with one of the roles that I've been preparing a while ago. It was to actually deploy the IBM Spectrum Protect. You need to prepare the storage and you have a set of drives. Now, once you have a set of drives, you would like to have a relationship with the appropriate mount points, and you have different requirements. You would like to resize the drive to the specific size and validate if these met certain minimums. Problem with that is that usually you would have multiple dictionaries or multiple collections, and so you would need to search somehow which property is matched against which other property to form sort of the single object. And in the object-oriented programming languages, it is usually you have a form of the structure. Now, in my case, I had that defined. Like I have here a loop that is a different way of actually writing the loop like I have in here. Notice that the syntax is slightly different. If you have more values to be passed, that's the even better way because it's more readable. You don't have so long lines. But this is the way you can use, you can merge all of these properties together and form a single list of the data structures of the objects that will have all of the information related to the specific device, to the specific, let's say, mount point, etc. So the device plus mount point plus anything else would be represented as the single item on your later on your collection. And how to create it? Okay, so you can use setFact, and actually there are two useful filters. One is default. So I would like to set a fact where I'm using as the base name with path. It doesn't exist initially as the base of my loop. Now I would like to define it as the empty list if it has not been defined earlier. So if it's not defined, then the default is going to be an empty array. And that's perfectly fine. Now, for every item in the loop, I'm going to union this list with the list of a single item. Okay, and this union module is actually going to append these quite complex entities into and merge them into a single collection. Notice that here I have invocation for every item, and the debug here actually forms a single variable, single array that has both objects here defined. Now it is going to be easier for me in the next steps to refer to the specific names and paths, so that I can write it to the file, or let's say mount it in my operating system. Okay, another example is that I would like to loop through contents of the local file. Okay, so this is a good example when you have an input file and you would like to traverse it. Maybe it's an output of the other application with all of the contents, and you would like to use each line as the input. So notice that I have here loop over an expression. So there is a lookup expression. Now, lookup is being used for the local files on the controller machine. Okay, it's not going to be on the system that you would expect it to be. Okay, and this lookup actually is going to get the contents of the file, host file. So I'm just using my inventory, for example, and it's going lookup. In this case, I would need also to split the lines, because I don't need the whole contents of the file. I would like to use these contents and split based on the line separator, so that I will have items generated for each line. And notice here that I have line entries. This is exactly the content of the of my inventory file. So it's a easy way to loop over a file contents if you would like to have a dynamic way to loop over some dynamic set of the items. You may also want to do that exactly the same for the remote file. So now you are executing the playbook on your local machine. You would need to fetch somehow the contents to your controller machine and then execute the loop. In my case, I'm using the slarp module. The source is going to be the file that has been generated as one of the earlier steps. And I'm going to register the encoded content of this module. Now, the contents are actually base 64 encoded, so I need to use this registered variable. I need to go to the contents property, decode it, and the contents that are decoded, then I would like to split with the line separator is /n. This is going to do exactly what you can see in here. This is the contents of the remote file that has been fetched first, and then we can iterate over the individual lines. Last but not least, something different than loop. Okay, because there are many other, there are a few other loop. Well, previously it was with something notation. Now it's a loop for most cases, but there are sometimes require the globals that you would like to use to traverse to execute specific task for every file that has been found in a specific location, etc. But in most cases, you're going to use just loop, or optionally some lookup, some filters. Now, sometimes you would like to have a loop until some condition has been met. So in the regular shell script, you would have, well, there is an until as well, but let's say while loop. In this case, I'm executing a shell command, which is going to have a random exit code. Well, random is going to just randomize 1 or 2. So we are going to flip a coin up to 10 times. So notice that I have the until clause. I would like to flip this coin until 1 is being generated. I would like to retry this task up to 10 times. If it succeeds earlier, then I'm good, okay? And I would like to have 1 second delay between each retry. This is very important concept actually in Ansible, because it's really handy when you have a starting service which let's say you have used systemd to start the process itself. Now you need to wait. Systemd has reported that okay, it started, but the API still doesn't respond until allows you to repeat, let's say, login attempt several times, and once you have the server up and running, you finally you're going to have this task being executed. In my case, I have 10 and retries 9, so it has tried 3 times, and then finally this shell command has reported different value than 2, okay, because it had to be 2, it had to be 1, and it reported 2 several times. So in this case, whenever I rerun this playbook, it's going to have different amount of different number of retries with every time. It's very handy. Remember that you, in my case, because I'm using exit command, I had to put the failed when clause in here. Failed when allows me to specify the condition again on the task when it is supposed to be assumed that it has failed, because exit 1 or 2 is in both cases means an error, and in my case I just wanted to assume that 2 is not what I want to have. I would like to collect 1. Okay, so that concludes my demo. Thank you for today's session. Actually, it took much longer than I anticipated, but thank you for still being until the end of this webinar, and stay tuned for the other webinars.